Okay, so for this unit, guys, obviously it is very, very short. All right, there's not that much material in it. Okay, so that's the good news. That means you don't have that much stuff that you need to study. But what I am going to do today is give you a pretty good idea of how you're going to need to study it. Okay, I'm going to tell you basically how I'm going to ask about each of the things so that you can start preparing in your mind for that. All right, everybody with me on that? Okay, because I mean you really only have a few days left in order to do that. Okay, couple of other reminders. Okay, if you completed any of your overdue assignments, okay, last night so that they were ready for the 2 o'clock deadline today, make sure that you have submitted them on Google Classroom, right? Because basically I'm just going to go through and look and see if it says done. If it still says late, then I'm not even going to open it. Okay, because I'll just assume it isn't finished. All right, so make sure that you have it submitted, right, so that I know when I go through there today, okay, whether it's done or not and whether I need to mark it. Remember that your final exam, okay, on Friday of next week, uh, in the gym, 9 o'clock. Be here for 8:45 at the very latest. That's when we'll begin loading the exam, okay, letting you in and going to your desks and whatever. You won't have a locker by then, okay, because you'll be asked to clean those out on Tuesday. So you will have nowhere to put your electronic devices other than in the like basket or whatever they collect there in the administrator's offices. So I would say advisable to leave it maybe at home. I know that's difficult for you, but okay, leave it at home or leave it in your car or somewhere else, okay, because you cannot have any electronic devices other than your calculator in your final exam. So please make sure that you do something with that, okay, prior to that time. For your final exam, here's what you need to bring. Some writing utensils. You might want some pens. You might want some pencils, maybe like 2 of each. Right? That way if you break a lead but you still need a pencil, you don't have to wait for someone to come around and get you a new one. Okay, it's always a good idea to have 2. Your calculator, and if you have like a TI-83, make sure it's got a fresh set of batteries in it. Okay, because I will come around and clear your calculator prior to the exam. And if your calculator's batteries are low, I can't clear it. And it'll just give me a notification that says batteries are low, please replace, which means I put it under my arm and I go around and I clear all the other calculators. And then I saunter down to the office and I grab some batteries. I put them in your calculator. I clear it. I take them out. I put your crappy batteries back in, and I saunter back down to the gym. Okay, that might take me a while, and all that time you will be without your calculator. Okay, since that will add stress to you in an already stressful situation, eliminate a source of stress by buying 4 AAA batteries, okay, this weekend and putting them in your calculator for next week. All right, that way you don't have that problem. Then also advisable would be to have some water, okay, maybe like a exam appropriate snack of some kind, okay, like a granola bar or a piece of fruit, with the exception of an orange. Because if you gotta peel that thing, your hands get all sticky. I watched a kid do it once. I was like, hey, that kid brought a healthy snack, and then I watched him the rest of the test all sticky. Okay, and so yeah, maybe bring something like a banana or an apple, okay, something like that that can just give you kind of a quick shot of sugar, okay, keep your brain going when you start to get low blood sugar around 10:30 or so. Okay, everybody with me there? Okay, so those are the kind of things that you'll want to make sure that you bring, okay, and obviously your electronic devices you want to leave at home and not bring. Um, you have 2 hours to complete the test, okay, from 9 till 11, and that's it. At 11 o'clock, it's over. Right? Unless you have an allotment for extra time, but I don't think anyone in here does. So just know that that's how long you get. You'll have to manage your time effectively, okay, through there. Yeah, I've made the key up for the test, and I don't think time is going to be a factor. Okay, I think that most of you will probably be done between 90 minutes, okay, and maybe an hour and 45 minutes. Right? That'll give you time to check it over. If you're done in under an hour, A, I'm almost certain you failed. B, okay, you have to stay in the exam writing area for an hour anyway. So yeah, don't finish in under an hour. Right? I just don't effectively think you can write the test in under an hour. Yeah, You don't need to bring anything else other than your writing utensils and your calculator. You'll get a fresh periodic table and a fresh formula sheet, okay, for the exam. Because I mean, some of you might have lost your periodic table. I don't know how much you wrote on it. Okay, so you will get a fresh one, and it's exactly the same one you have. All the special elements are highlighted and everything on it's in color. Okay, so you'll have everything on you need. Questions there? Okay, let's get to the unit exam review then. First thing we went over in this unit was climate. Okay, that means we need to know the difference, especially the difference between the components of climate. Okay, and the components of climate are temperature, precipitation, light, and wind. Okay, the things that we would associate with weather. Okay, and then we need to know the factors affecting climate. Okay, and that's what the climatogram activity that we did was all about. Okay, was locating which factors affect climate. So remember, that's things like latitude, altitude, mountain barriers, proximity to the ocean, ocean currents, centers of high and low pressure. Okay, all of that stuff. Those things can affect these things. Okay, so your latitude affects the quality and intensity of light that you receive. Okay, it may affect your temperature as a result of that. And depending on where you are, it may also affect your patterns of prevailing winds. Right? If you're near the equator, your prevailing winds would be out of the east. If you're up here where we are, your prevailing winds are out of the west. Okay, you guys kind of follow me there? Right? Those factors affect the components of climate. Here's how you're going to be tested on that. Okay, I'm going to give you a question that has a map with a location identified on the map. You'll need to tell me what factors most affect the climate of that area and how they affect the climate of that area. So you would tell me, I think that this area is heavily affected by the presence of mountain barriers. This location is on the leeward side of the mountains, meaning that it will be in the rain shadow, so it will have low precipitation. They will likely have cold winters because they're not near the equator and they're not near any oceans. Okay, basically I'm describing Okotoks. Hint, it's not Okotoks on your test. Okay, that kind of thing. So you would need to tell me, here are the factors, and here's how they affect the climate, and here's what the climate would probably be like. Does everyone follow me on that? Okay, so basically it's exactly what you did in your climatograms activity. Okay, it's just going to be for a specific city, and I will identify its location on the map. All right, everyone with me there? Okay, so it's very much an apply your knowledge question. Now, are there going to be some multiple choice questions about this? Certainly there are. Okay, there could be some questions like, which of the following is not a component of climate? And there would be a list of 4 things. Okay, things like that. Okay, questions on that part? All right. Okay, at the end of that lesson, we introduced climatograms. You will need to be able to interpret what a climatogram is telling you about the climate of an area. Okay, and as I said yesterday, what you will be required to do is, I will give you a climatogram, and you will need to tell me which of the biomes from yesterday it comes from and why. All right, probably be about a 5-mark question, so make sure that you give me lots of detail as to why you think that climatogram is telling you, okay, that it comes from a specific area. All right, so if it had like a flat temperature line, you could tell me, it's definitely near the equator because the temperature line is flat, but the precipitation all comes in a 3-month period, so this is probably savanna because they have monsoons and they're near the equator, so the temperature is even, okay, but they have long extended dry periods, blah, 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 okay, something like that. Okay, so match. We'll just write match with biome. And explain. Okay, energy transfers. Okay, that was that really long lesson that took me to, well, you guys watched a podcast of it on Friday, June the 5th, and then I finished it up on the Monday. Okay, so this is also, I mean, some of this will be multiple choice stuff where it's, asking you about, hydrosphere and lithosphere and things like that. And there would probably be some multiple choice questions about what conduction, convection, and radiation are. So let's just quickly review here. When light hits the Earth's surface, anywhere on the Earth's surface, three things can happen to it. Does anyone remember what those three things are? Okay, it can bounce right off. We call that reflection. Okay, will there be any change in energy if the light just reflects off the surface? Will it warm up, cool off, or do anything if it just bounces off? No, if it just bounces off, nothing happens. Okay, and what determines how much of it bounces off? We had a special word for that. Started with A. Better look it up. Someone can look it up. Lesson 2, about the third slide. I'm pretty sure, second or third slide. It was in italics. Has to do with the reflectivity of a location. Jason. Albedo, right. Okay, so reflection can happen, okay, and that's how much of it reflects is determined by the albedo. A high albedo means high reflectivity. Low albedo means high absorption. Okay, all right, there's the second one. It can be absorbed. All right, and we said things like dark colors tend to absorb more sunshine, and as a result, the temperature and the energy will go up. What's the third thing that can happen to light? It can be reflected, it can be absorbed, or it can be no, can't be. Well, I mean, there's always a little bit of both. It's never one or the other completely. It happens if it hits plants. Right. Okay. It can be used for photosynthesis. We would say converted, okay, would be that third thing that can happen, okay? And it can be converted by photosynthesis. Okay, into chemical energy. That's the three things that can happen to sunlight when it strikes the Earth's surface. It'll just reflect, it'll be absorbed, or it will be converted. That's one of the most important things out of that lesson, okay? Because it leads to the next thing, and that is, if it is absorbed, how does it get transferred from one place to another? There's three methods of heat transfer. Okay, and those methods of heat transfer are conduction, convection, and radiation. All right, there will be a question about each of these things, right? A written response question, right? I'll ask you, here's what's going on. Sunlight is striking a particular place. Tell me what's going to happen to that sunlight, okay? And you need to basically, think about that area and think, okay, what's that area like? How much of it's going to be reflected? How much of it's going to be absorbed? Are there a lot of plants? If there are, is a lot of it going to be converted by photosynthesis? Do a little bit of explaining, okay? That'll be one of the things. And then there's going to be an application question about conduction, convection, and radiation, the methods of heat transfer, right? Conduction only occurs in what state? Solid, liquid, or gas? Solids. Okay, so it occurs in solids. Okay, is it very effective? Like, does it transfer over large distances? It does not. Okay, it does not transfer over large distances. What you're going to be asked to do is either you're going to be given a situation where either you want to be harnessing the sun's energy and transferring a lot of it, or you're going to want to be insulating something and keeping as much energy in as possible. Okay, so in one case, you'd be asked to use these three methods of heat transfer to catch as much energy as possible, whereas in another one, you'd be asked basically to reflect as much of it as possible. All right, everyone follow me there? So we're going to have to think of practical ways, okay, that we can do that. For conduction, if I want to get a lot of stuff, a lot of the energy that's being absorbed in, what kind of things do I want to make that stuff out of? Now I want it to be dark so it absorbs a lot of the energy, okay? And what kinds of materials typically transfer energy by conduction very well? Okay, like I'm thinking here is wood a good conductor of heat? No, it's not. Are metals a good conductor of heat? Yes, okay. That's kind of the line of thinking you need to go through. All right. For convection, okay, convection is heat transfer in which state or states? It would appear you guys have a lot of work to do this weekend. A little disappointed we don't know a lot of these answers. Liquid and gas. All right. Convection happens in liquids and gases, okay, by currents. Hot air rises, cool air descends. Same with water. Okay, so if I want to transfer a lot of energy by convection, I might even have something in there that will assist the process. That is maybe like a fan or a pump, okay, that can help to move the material more quickly, okay, and transfer the energy and kind of increase the rate of convection. If I am trying to prevent heat loss by convection, then I want to insulate. And I want to do anything that will prevent the movement of that fluid. And we talked about how when you put that fiberglass insulation in your walls, there's a whole bunch of air inside of that that is trapped and can't move. And as a result, a convection current can't get set up in your wall, and that prevents heat loss by convection through the walls of your house. You guys remember us talking about that? Okay, those are the kind of practical application things you're going to have to do. All right, and then radiation is any heat transfer that occurs through waves. Okay. And that's where we want either dark colors for absorption or really light colors, okay, for reflection. In the podcast, when we talked about radiation, I talked about how lots of people screw up their barbecues by putting the tin foil on the baked potatoes the wrong way. Okay, if you've ever noticed, right, tin foil has a shiny side and a dull side. Right? And that is so that one side absorbs radiation and heat very effectively. That would be the dull side. Okay? And the shiny side reflects it. So which side should be in for a baked potato? The shiny side needs to face the potato. You need to wrap with the dull side out and the shiny side in. Here's why. The dull side will absorb the radiation. It will go through the potato. As it goes through the potato, it strikes the shiny side on the other side and reflects back through the potato again. Right? The more times you can reflect that light back and forth inside the potato, the better, the faster it will cook. If you put that thing and you wrap it in there with the shiny side out, it's just going to reflect the heat away, and it will take forever for your baked potato to cook. Or worse, you'll pull them all off of the barbecue thinking they're all cooked, and someone will get a crunchy potato. They will probably not be very happy about that. I know, I wasn't. Okay? Is that making sense? Practical application stuff, guys. That's what you're going to be asked to do. Okay? And then also within that lesson, we talked about lithosphere, hydrosphere, and atmosphere. Okay, and we talked about how they transfer energy. Okay, which one of those is the most important for transferring energy on a global scale? Nope. The lithosphere, remember, is all solid, so it's conduction, and conduction doesn't work over big distances. The which? No, that's what she just said. The lithosphere is the solid part of the Earth. It transfers energy only by conduction, so it's no good for transferring energy. Which one of these three is in contact with all parts of the Earth and is most fluid? The atmosphere. That's where what occurs? Wind. Okay, guys, you really got to go over your stuff this weekend. There's not that much stuff in this unit, but you got to know it. Okay? Guys, honestly, this test, if you prepare for it, is a huge opportunity to boost the exam portion of your mark because there's not that much material on it. But if you come in on Monday thinking, oh, there's not that much material, I'll do fine, you're wrong. Okay? And you're not going to like what happens. Okay? Make sure you're well prepared for this test. All right, so atmosphere is the most important because gases are the most fluid. Okay, convection occurs most readily in there. Okay, and that convection we call wind, and that was what the whole next lesson was on. Okay, we talked about winds. Okay, now the three ways that energy is transferred, okay, within the Earth's atmosphere were convection, that's wind. Latent heat, okay, that's evaporated water that's moving from place to place. And there was a special wind that we talked about in this lesson called the jet stream. Okay, remember, okay, the big three. Okay, I would guarantee you that there is a question that asks about how does energy get transferred within the Earth's atmosphere, or how does it move from an equatorial location to a polar location? That's the big three. Okay. Okay, within this lesson we also talked about the patterns of prevailing winds. Okay, and prevailing winds are the product of two things. Okay, convection and the Earth's rotation. All right, the second law of thermodynamics is causing air to move from hot to cold, and the Earth is spinning under it as that happens, and that causes patterns of prevailing winds. Okay, you had the picture of the Earth with those convection currents, okay, at the three different areas there, right? Looked something like that. And then it had the Earth rotating this way, and then it had that, okay, that kind of stuff on there. Just remember that. There's going to be a question, probably will have that picture on it, okay, asking you to explain how prevailing winds occur. Okay, so you'll be asked to explain how they occur. All right, and then we had a special name for the effect that is caused by the fact that the Earth spins under its atmosphere. Does anyone remember what that was called? Coriolis effect. Probably be able to explain what it is. Okay, and obviously it has something to do with the prevailing winds as well. So it could be part of two questions in the written response. One simply about the Coriolis effect, and one about prevailing winds. Okay, next thing we went over specific heat capacity. Um, there'll be a couple of multiple choice questions about what it is, maybe about its units. Okay, but there is a 5-mark problem solving question in the written response that is a specific heat capacity problem. Okay, so that's that E equals MC delta T. So you'll have to solve for something in that formula. Okay, write your givens down and figure out, I don't know, what the material is, or what the change in temperature is, or what the mass is, something like that. Okay, and on the test I will give you that formula, and I will give you, either in the question I'll give you the specific heat capacity, or I'll give you a chart of specific heat capacities on the front page or something like that. Okay. Okay, there'll be some multiple choice questions about what latent heat is, about its role in energy transfer, which we kind of already talked about. Okay, it's one of the big 3 in terms of moving energy from the equator to the poles. And an 8-mark problem in the written response. Okay, and remember that that will involve water being heated and the heating curve of water. Right? When we have a latent heat problem, we identify the starting point and the ending point. Okay, so let's just say that it started at 50 degrees Celsius and it ended at 150 degrees, let's say 120 degrees Celsius. Okay, how many steps to that problem? 3. Okay, if I'm starting at 50 degrees and I have to move to 120, the first thing I have to do is heat water from 50 to 100 degrees Celsius. What formula do I use to figure out how much energy that takes if there's a temperature change? Right, E equals MC delta T. Okay, and which C do I use? Remember, water, ice, and steam all have different heat capacities. Okay, that was one of the places where people mess that up. Okay, once I get water to 100 degrees Celsius, if I keep adding heat to it, its temperature won't change, but it'll start to what? It'll start to evaporate. What formula do I use to figure out how much energy it will require to evaporate? Sabina? E equals MLV. Okay, the latent heat of vaporization. Once I've evaporated all the water, I'll be heating the steam and changing its temperature from 100 to 120 degrees Celsius. Oh, sorry. And then biomes is your last thing. Multiple choice questions with a picture and a description. Okay, you'll have to identify which biome is being talked about. And obviously the climatogram question that we already talked about will have to do with biomes. That's what's on there, guys. Gives you a pretty good idea of the types of things you're going to need to know and how you're going to need to be able to talk about them. Right? There's a lot of application type stuff in here. Right? So think about those kind of things. On your unit exam review sheets, okay, there's a lot of stuff in there, okay, that kind of talks about that. There's a specific heat problem, there's a latent heat problem, okay, and the last question that's on there is one that I've had on tests before that asks you basically to do some higher level thinking. It says, from your knowledge of latent heats, explain how the water cycle can be a source of energy for an area. Okay, so the water cycle involves evaporation, precipitation, runoff, all that kind of stuff. Okay, When water is evaporated, energy goes in. All right? When that water condenses and falls as precipitation, the energy is given off. Is it going to be in exactly the same place, or is it likely that that latent heat got moved to another place? Okay, that's how the water cycle can be a source of energy for an area. There is going to be a question something like that on your test. It's going to ask you to explain how the water cycle, how latent heat could maybe affect the climate of an area, or affect the amount of energy in an area, or affect the amount of water available in an area. Okay, there's going to be one higher level thinking question like that. Okay, but it gives you a pretty good idea here as to the kind of things that will be asked. Okay, so make sure you go over those things. Okay, like I said, there's not that much for you to go over, so you should be able to go over it in detail. Okay, and that's what I'm going to be expecting for Monday. Are there any questions? All right, well, you've got about 15 minutes or so. Okay, you can do some independent studying. Independent being the key word there.